Hi, I'm Paul. In this video, I'll give a high-level overview of how Coinbase's x402 payment protocol works. First, we need to understand the core basics of HTTP. You've probably seen those letters before in your internet browser. HTTP is a protocol that defines the core communication structure of the internet, detailing how a client requests information or actions from a server and how the server responds. A client can be your smartphone, a laptop, another server, or even an AI agent. The typical interaction begins with the client making a request to a server for something, for example, a web page or an API request. HTTP defines how this request is structured and transmitted across the internet. The server processes the client's request and sends back a response that is also structured and defined by the HTTP protocol. Depending on the request, the response can be as simple as API data with just text, or the content of a web page, or even an actual file for download. But what is really important in the response is something called the HTTP status code. This is a standardized 3-digit number that tells the client what happened with its request. These status codes were defined in HTTP's first major standardization in 1997. If you've been using the internet long enough, you've surely seen these common status codes. 200 means OK. Everything went well. 404 means the resource you requested could not be found. 500 means something went wrong at the server. And then there is 402, which was reserved for payment required. HTTP envisioned a scenario where a server would require payment before handing over a requested resource. But the status code didn't get much adoption as the internet grew. Instead, other mechanisms, like payment forms and paywalls, became the standard way to require payment first. With x402, Coinbase is the first major player with a highly adopted implementation of that status code. Let's break it down. x402 operationalizes the HTTP 402 status code for internet-native machine-readable payments. When a client requests a paid resource, the server returns a 402 status. Coinbase's x402 defines how this response should be structured and how to perform subsequent actions as a result of this response. Let's look at a simple example. The client sends an HTTP request for a paid resource, in this case, a premium PDF report. The server responds with an HTTP 402 status and a payment required header. This header is metadata defined by the x402 protocol. It contains encoded data with instructions for making the necessary payment. The client decodes this header data, revealing the payment instructions, which include the required amount, the accepted payment methods, and the recipient's payment details. As of this video, the latest x402 release supports stablecoin payment methods, as you can see from the decoded payment detail in this example. I will save the specifics of stablecoin and crypto payments for a future video. However, a good way for you to understand these payment details is to think of the network field as something similar to traditional bank transfer networks. Asset is like currency, while pay-to is basically an account to receive the funds. Next, the client selects one of the available stablecoin payment methods and generates a payment authorization payload based on the provided payment details. This payload is then signed by the client. All this is happening automatically on the client system or AI agent, without a human in front of a screen. The client then encodes the signed payment authorization payload and puts it in the payment signature header of a new HTTP request to the server, requesting for the same resource, the premium report PDF. This request is identical to the first request, only this time it now has a proof of payment embedded in it. Again, all this is happening without human intervention. The resource server then verifies the payment authorization, usually by involving a third-party facilitator. The facilitator is similar to a PSP in traditional payments. However, for stablecoin payments and this example, the facilitator doesn't touch the funds. It simply checks and confirms the payment. Facilitators are optional. The server can also have capability to verify stablecoin payments directly. However, facilitators do help reduce complexity and scope. Once the payment is verified, the resource server grants access and responds with the requested premium content back to the client. The value exchange has been completed successfully. Let's compare x402 stablecoin-based payments to card payments in agentic flows. x402 offers lower merchant registration and KYC hurdles compared to the card payment acquiring equivalent. It allows for machine-only execution, which is not always possible on cards, especially when things like 3DS come into the picture. It is ideal for micropayments due to very low fees. With cards, it is often impractical to scale micro-value payments because PSPs often charge a flat amount, plus a percentage per transaction. The flat amount is often higher than the intended micropayment amount. Chargebacks are not possible in these stablecoin flows. The payments are final with instant settlement. You can see how Coinbase with this protocol is positioning itself for a world in which AI agents autonomously interact and transact with other AI agents. By upgrading the web's foundational communication layer, rather than stacking more software on top of legacy banking networks, protocols like this show us what a friction-free, machine-executable economy may look like. Here's some key takeaways. X402 builds on the long dormant 402 HTTP status code, which is several decades old. Second, the protocol is built to be entirely machine-executable, without human involvement at all during checkout. Third, its initial stablecoin focus allows for immediate settlement and direct participation in payment processing, without the need for PSPs and other third parties. Client and merchant are able to execute and settle stablecoin payments directly if they like. However, the protocol does allow for a PSP-like facilitator role to take away some of the complexity and help authorize, verify, and settle payments, allowing client and merchant to focus on what they do best. Finally, the protocol is open and extensible. It will evolve, and other players can contribute or spin off their own versions capable of supporting additional payment methods, including cards. And that's it. Thank you for making it this far. Follow me for more agentic payments breakdowns, and I'll see you in the next one.